Okay, so good afternoon, everyone. Let me introduce myself. My name is Abdelrahim. I'm from Jackson State University. I'm a PhD candidate in my 4th year, and my research is focused on bias in artificial intelligence, mainly in automated lending systems. And I choose a field of lending system financials, but this study, of course, can be expanded to any automated lending system that can affect hiring, can affect school admission, can affect healthcare. My advisors are Dr. Hong and Dr. Kwembe. Let me start with an introduction, a brief introductions about AI/ML algorithms. Right now, we can see that there's a huge expansion in the dependency on AI/ML. We can hear AI in almost everything, in predictions, in Google Assist, in ChatGPT. But mainly now they are depending on using artificial intelligence in automation of the decision making. They're trying to reduce or minimize the human being intervention in taking the decisions to avoid any lack of experience for inclusion. But this comes with a huge downside that we know that ML models, algorithms, they are considered black boxes. Is that all we know is the data that we feed to algorithm, and then at the end we can see the prediction. How did the algorithm comes up with the outcome? It stayed for a long time like a black box. It's unexplainable, and it's like you have the result, take it or leave it. Our research aims is to detect the potential existence of bias. And if it's there, we're gonna address it through treating of the data imbalances in sensitive attributes, race and gender, in order to mitigate bias. Our ultimate goal is to enhance ethical fairness in decision-making systems. Our methodology is going to be in a multi-directional approach. We're going to look at the data, pre-processing. We're going to look at the algorithm, post-processing. We're going to use some bias metrics. We're going to use explainable AI to try to understand how did the algorithm come up with the outcome. We're trying to add some transparency on the performance of the algorithms. The reason that we go through a multi-directional is like at the end, we want to assess which is the effective way of detecting and addressing bias. So let me just go through some definitions. We're going to use those terms quickly. Bias is the tendency of the algorithm to favor certain groups based on certain demographic characteristics. And through the research and the literature review, it was proven and shown that AI systems, whether in lending, in healthcare, in criminal justice, in hiring, there is some racial and gender biases because the data that is used on the systems is like an old data. We use big data. So we face the issue of historical bias that it's going from dataset to dataset. Discrimination is the action that is taken based on biased outcomes. It leads to unfair treatment of the people. And of course, the ultimate goal is to avoid discrimination. When we started investigating bias to see where the source of bias in order to see the best method in addressing it, bias, it can be in any stage of the life cycle of the machine learning. It can be in the formulating of the research problem. It can be in the data collection. It can be in the pre-processing of the data. Of course, all these lead to an algorithm being biased because the algorithm only knows the data that you give to the algorithm. And in the model implementation is that when we have the prediction, we don't do anything about it. We just take it as is and we apply it to the applicants. Our research design, it's going to be, we have to assess the bias, try to quantify it before any fairness intervention. And we're going to do that in the data, in the training models, through the metrics, and trying to explain the outcomes. And then we're going to propose our method in addressing the imbalances to treat bias. And then we're going to reassess again with the same metrics for the sake of integrity. So when we started with the data exploration, our data source was the HMDA, Home Mortgage Disclosure Act. It's a big source, data source of data. It has lending and loan information nationwide for years. Our data sample are 3 years, 2014, 17, 20, for 6 southern states. And when we look at the loan distribution for 3 years, we can notice that the approval, the number of loans that were approved way exceeds the number that they were denied. That might look very attractive at the beginning, that, oh, the system is really giving approvals. But we need to break down the approvals in terms of race and in terms of gender. We can see that if we look at the race distribution, given that the male applicants way exceeds the female applicant, and if we look at the loan approval rate, there's always a disparity between males and females. Through all this presentation, when we mention protected group, we're going to refer to females and Black, and the non-protected group, it's males and white. Also, the protected group, female and Black, we call them sensitive attributes. And we can see that the system is in favor of males against females. If we look at the race, we can see the same disparity in the number of applicants. I'm not talking here about approval. It's only the distribution of the applicants. We can see that the number of white way exceeds the number of Black applicants, and the loan approval, the disparity is way much bigger than the disparity that we noticed in the sex or gender attribute. This we can define it in a term called data imbalances. It occurs when certain groups are underrepresented in the training data. That might be caused for lending practices. It can be caused by socio-economic factors, but at the end, we are dealing with a data set that is imbalanced, and treating imbalances is our target in this research. If we look at the algorithm, we chose 3 models, logistic regression, data decision tree, and random forest. The performance in general was very reasonable. We didn't detect way unfair treatment, even in terms of precision. The precision, of course, is if all predicted positive, how many were correct, and recall how many did we deny that we should have given the loan. In lending system, both are important, but we need to balance it. We don't want to be very strict, and we don't want to be very relaxed because we want to minimize risk. The main metric for us to detect bias was the equalized opportunity metric. It is the difference between the true positive rate of the protected group minus the true positive rate of non-protected group. As the much it's closer to 0, we can say that our results are fair and they are not biased. The more it's far, whether it's positive or negative, far from 0, it indicates a potential bias. And if we look at females versus males, in general, it's around 0.4, 0.4. But for Blacks to whites, it's 0.7 for all models in all 3 years. So here again, we can say that the bias towards race is more recognized. And that's why in our strategy, we focused on treating the bias in the race. Our last avenue in trying to understand what's going on is that, okay, race and sex, we have disparities, but were they very important in the decision? We can see from the SHAP, explainable AI, that they played a major role in predicting the result. Now we're gonna move to our strategy. We opted from removing race from the training algorithm. In fact, we wanted to maintain the information, but we wanna spread the distribution by merging it, aggregating it with a non-sensitive attribute. We selected income because logically income plays a role in the lending decisions. Now, if we look at the data distribution, we can see now the disparities is way less than before, and we focused on 217. It went from around 15 points to almost 10 points. The algorithm performance kind of stayed the same, so that was not a very highly indicator of bias or whether we have accomplished something. But when we look at the equal opportunity metric, it dropped from 0.7 to almost near 0. And that is indicate that our strategy really worked in enhancing fairness. Our work, of course, can be expanded to other areas. It can be expanded to other sensitive attributes. Realistically, we cannot say that we can achieve zero bias, but the less bias that we can enhance, it makes a good progress in our research. Thank you. And if anyone has any question,